Okay, so this is the beginning of Chapter 10. Chapter 10 kind of has two parts to it. The first part is about 3D objects and how to deal with 3D objects, and then the second half is how to do surface area and volume with 3D figures. So let's get some vocabulary going. 3D figures or solids can be made up of flat or curved surfaces. A flat surface is called a face. An edge is a segment that is the intersection of two faces, and a vertex is the point that is the intersection of three or more faces. So you can see on this diagram here of a rectangular prism, all the planes are all faces. Edges are line segments where two faces touch, and then vertices are points where three or more faces come together. So in this case, this is 3. So each of the corners is a vertex. Okay, so now we have different kinds of 3D figures. So a prism has two bases that are the same. So, and then it has rectangles or parallelograms, either one, around the middle. So this is a triangular prism. It's a prism because there's two bases, rectangles around the middle. It's a triangular prism because the two bases are triangles. Here, a cylinder, two parallel congruent circles as bases, and then a curved surface that connects everything around the middle. A pyramid has one polygonal base, and then it has triangular faces that meet up at the top. So this is a triangular pyramid because the one base that it has is a triangle, and then of course there's triangles around the middle. And then a cone has a circular base and a curved surface that comes together at the middle. So cylinder and cone, you know for sure. The other two, you just need to first decide, is it a prism or is it a pyramid, based on how many bases does it have, 1 or 2, and what shapes are the sides, parallelograms or triangles. So once you get it narrowed down to that, then you can look at the base and say what shape is it, and then you'll know both words. A triangular prism, a square pyramid. So you'll have both categories taken care of. Okay, a cube is a prism with 6 square faces. Other prisms and pyramids are named for their shape of their bases, which is what we just talked about. Okay, so let's practice naming these things. Alright, so here we have 2 bases and parallelograms around the middle, so we know this is going to be a prism. The bases are triangles, so this would be a triangular prism. Here it's a prism because there are 2 bases and rectangles around the middle. The bases are rectangles, so it's a rectangular prism. Here, there are 2 pentagons for bases, parallelograms around the middle. So a pentagonal or a pentagonal, depending on how you want to say it, prism. Here are 2 hexagons as bases and parallelograms around the middle. So a hexagonal or a hexagonal prism. Okay, pause here and do the second step. Okay, this is going to be a triangular pyramid. Triangles around the outside, triangle on the bottom, triangular pyramid. Square pyramid. Oh, I guess I gave you all the pyramids. Whoopsies. Pentagonal pyramid. And hexagonal pyramid. Okay. Alright. Classify the figure. Name the vertices, edges, faces, and bases. Oh no, just bases. Okay, so first of all, this figure is either a cube or it's a rectangular pyramid, a prism. We don't know which because we can't tell if these are exactly the same. We'll just go ahead and call them a cube because it looks that way, but we would probably want further evidence later. Alright, vertices are all the points in the corner. So we have A, B, C, D, E, F, G, H. Edges, we know, are all the line segments. So we have A, B, B, C, C, D, D, A, E, F, F, G, G, H, should I put more room, H, E, now around the middle, A, E, BF, CG, and DH. Okay, so when you're having to list all these out, it's best if you just pick an order and go with it. So I went around the top, around the bottom, and then around the middle. That way you don't miss anybody. And then the bases would be square ABCD, and square EFGH would be the bases. Okay, pause here and do it for part B. Okay, part B is a pentagonal pyramid. Oh my gosh, I'm having a hard time writing today. Vertices A, B, C, D, E, F. Edges A, B, C, D, D, E, B, C, E, F, A, E, A, F, B, F, C, F, and D, F. The base, there's only one, would be a pentagon A, B, C, D, E. Okay. A net is a diagram of the surfaces of a 3D figure that can be folded to form the 3D figure. You already know what a net is. To identify a 3D figure from a net, look at the number of faces and the shape of each face. So here we have 6 squares. So I can tell this is going to be a pyramid, a prism, because it has 2 bases and it has rectangles or parallelograms around the middle. More specifically, this one is going to be a cube because all of them are squares. Okay, what do you think about B? B is going to be a cone because it's going to have a circular base, and then this is going to wrap up and fold together like this, where this curved edge is going to come and wrap around here. And then this is actually going to be your slant height. If you can picture that this folds up, here's your slant height right there, is that. We'll practice more of these tomorrow in class. We'll go through all of them so you make sure you know what all the different figures, what their nets look like. Cross section, this was actually on your EOC last week, or this week. A cross section is the intersection of a 3D figure and a plane. Describe the cross section. So here we have a cross section that is cutting off the very tippy point of this cone. So since it's just cutting off that much, we would say that the cross section is a point. As this plane moved down further and further down, then we would, my drawing is really horrible. Then you would see that it's cutting in a circle bigger and bigger and bigger. Okay, so as I get closer to the bottom, it's getting closer to the actual base that we have. But from here, it just starts off really tiny, even a point, and then moves its way down. What about B? What is the shape of the cross section here? Okay, since this is a pentagonal pyramid, I'm cutting parallel to the pentagon, so I'm going to get smaller and smaller pentagons as I move up, but still pentagons. Okay, a piece of cheese is a prism with equilateral triangular bases. How can I slice the cheese to make each shape? So here's a hint. If I want to make the same shape as the base, I should slice parallel to the base. Okay, so you kind of have to imagine a triangular prism. Excuse my drawings, you'll figure out real fast this chapter that they're horrible. So if I want to make triangles, I need to cut along with the triangle. So I would want to cut parallel to the bases. B says, how would you want to make a rectangle? So then you would say, I want to cut perpendicular to the bases. So I would slice this little top piece off, and then I would have triangles, and I would slice further and further and further down. And that was actually the same question that was on your practice EOC this week, was this one right here, perpendicular to the bases. Okay, so 10.2, we're combining 10.1 and 10.2 because most of it's material you've seen in middle school. An orthographic drawing shows the 6 different views of an object. So here in the middle, I have a rectangular pyramid, and around the outside is showing all the different kinds. So on the left and the right, I have small triangles, and then the front and the back, I have big triangles. Left and right are congruent, front and back are congruent because this is a rectangle. From the bottom, if I looked at from the bottom, I would just see this. From the top, you're going to see the tippy point of this, And then you're actually going to mark that you can see these edges coming down until they stop and they form the rectangle on the bottom. So most of the time, the left, right, front, and back are mirror images of each other, but you have to be careful with top, bottom with figures like a pyramid. So I hope you notice the difference between the top and the bottom of the figure. Okay. Draw all 6 orthographic views of the given object. Assume there are no hidden cubes. So technically the front and the back are mirror images of each other, but just in an effort to save time, I'm just going to let you draw one of them, and then you have to know that it's reflected. Okay, so from the front, I can see that there are 2 cubes here, 1 cube here, and 3 cubes here. When you look at orthographics, you kind of have to picture that you're looking at it from like a mile away. From a mile away, I wouldn't be able to see that there's a little cube here and then this one's farther back. I would just see the general outline. And the general outline would be 2 cubes, 1 cube, 3 cubes. Now, I wish my cubes were even, but they're not. Okay, and then the back would be, if you were really going to draw the back, oh my gosh, sorry, excuse this. Pretend that that's all equal. But you would draw the mirror image of that. So for now, I'm just going to let you draw one to talk about both of them. But you notice like on your EOC or something that these would be mirror images of each other. Okay, left, right. So pretend I came over here and I was standing on this side. I would see this cube in the front. And then I would see the height right here of all 3 cubes right there. Okay, and then of course if you were drawn from the right, you would just reflect that and do the mirror image. Top, bottom. So pretend like you're in space hovering above this. You wouldn't see the different heights of these things. You would just see that there are 3 along the back and 1 in the front. Okay, and then again from the bottom, if you were looking from underneath, you'd see the 3 along the bottom and then the 1 in front. You wouldn't be able to see the height of those. Okay, let's keep going. All right, determine whether each drawing represents, now in between here we skipped a lot of section 10.2. There were the asymmetric dot drawings. This is called a 2-perspective drawing. Since you're not going to be required to actually physically draw these, then we don't need to spend 10 years teaching you how to draw a 2-perspective drawing. What you just need to know is to recognize them and answer questions about them. Okay, so here is our original figure, and it's very hard to see because it's black and white and it's blurry already, but basically it has a cube here, here, and here. So 3 cubes make this up. And the question is, does this 2-perspective drawing, does it match? So we would say no, because this has 3 cubes, whereas this has 4 in the new 2-perspective drawing here. Okay, if we cut out this guy, then yeah, sure, that looks the same. Or if we cut out this guy over here, yeah, that looks good. But this has an extra cube, so that's not it. Okay, what about this orthographic drawing of this figure? Take a second and pause and see if you think that this is the same drawing. Okay, we're going to say yes, because from the top and the bottom, I would just see 2. I wouldn't see height, so I would see 2 and 2. From the left and right, all I could tell would be that this stacks too tall. How about too high or too tall? But I don't know what those combos were. And then from the front and the back, I would see that there's 2 here and 1 to the side. So that's what I get front and back. So this one works. This one doesn't. Okay, see you tomorrow.